So let's talk to you about the engineering notebook. So in this presentation, I'll be talking about a number of things. But before we get started, it's important to clarify that there are many different formats used to document the engineering process. The one we use here is kind of best practices, industry standard, the one I like. And then as you gain experience, as you go on through college and you become a professional engineer, the company you work for may have a different way of doing it. You may personally may decide that a different method works better for you. But while we're in this class and while you're still learning, we are going to use this format. So in this slide, we're going to say what is an engineering notebook, why do we keep them, who keeps them, what do we put in them, what are the different sections that are in there, what does a page look like, what's the best way to lay all this out, and then we'll look at some historical examples because I think they're cool. So what is an engineering notebook? An engineering notebook is which you formally document the design process. Okay, and it is very, very important that this is in chronological order. So the things at the beginning of the notebook are what you did first, and then as you page through, you get deeper and deeper into the project. Um, if any of you are in the VEX robotics teams, you have to keep a engineering notebook. And if you look at the start, it's when you're analyzing the game itself and maybe how you plan to score points. And then as you go through, you see, okay, now I've started building my robot. Now I've started to do an autonomous mode. So it gets more complex as your robot gets more complex. All right. You need to maintain a clear and detailed description of your design process. And the reason we do that is what we call the hit by a bus theory. If you go outside and you get hit by a bus, can somebody take over your project without any additional information? That's the hit by the bus idea. And that's where your notebook should read. You should be able to get in there, flip through it, and everything is there. So why do we keep an engineering notebook? The main reason that companies do it is it's a legal document used in patent activities. All right, it shows who came up with the idea first. All right, it proves, and I guess there's a difference between proving and showing, right? Proof is legal to use in the court of law. So it proves when events or ideas occurred, prove diligence in turning the idea into solution, and prove when an idea became a working solution. Now those last two used to be, when I was going through school, were much more important. Okay, the way the law used to work prior to 2011 was that the United States used something called first to invent. So whoever invented it first, as long as you were making it, turning it into a solution, and you were working on patenting it, then if somebody else patented it first, then you could come back if you had your engineering notebook and prove that no, I did mine a month before him, and then could award you the patent for that. In 2011, the United States joined the rest of the world, literally, and simplified the patent process by changing to a first inventor to file format. And you can kind of see this here, the first inventor to file. All right. And that means whoever gets their documentation in first to the patent office, that is the person who gets the patent. All right. So who uses an engineering notebook? Engineers. All right. Engineers that work in research and development. I would go on and say all engineers. All right. It provides legal documentation of their work. And this is even more important with the first inventor to file format. The engineering notebook is not quite as important as it used to be. However, as an engineer, and when I worked as an engineer, the engineering notebook became the one place that I could go to and look back in my project if I had a problem and wanted to remember something I'd done before. All right, so it provides a continuity in your project. All right, all the information I need for my project is right here in my hand, and that's really the power now of an engineering notebook. Engineering students, that's you guys. You are going to use an engineering notebook. All right. High school and college students, both will use an engineering notebook. I think this is important because it helps you develop time management skills. It improves your research, documentation, and communication skills. All right. When you look at folks your age, you're not necessarily quite as thorough as you need to be. To look back at something 6 months from now and realize, what was I doing and what was I thinking? We're going to improve that using our engineering notebook. It's also the basis for the presentation of your work. If you're in VEX Robotics, you have seen this. What do the judges do when they come see you at a competition? The very first thing that they should ask you, or they do ask you, is, can I see your engineering notebook? Okay, that becomes a presentation point for your entire robot. All right, same thing if you're an engineer and you have a job. That will be a presentation point. You can go back and look at your test results that you made 3 months ago. All right, and you can put those into your slide. For maybe you're asking for additional funding. Maybe you're showing the sales force what all you did to create it, so they are knowledgeable enough to go out and now sell it. All right, so let's look at what the contents of your engineering notebook should be. All right, in essence, all right, at the very simplest, it should contain everything, every single thing related to a design project. Easy, okay? If you did it, if you think it, put it in your engineering notebook. All right, everything you do or think about with respect to that design project should be in the engineering notebook. All right, if you want to keep it if you want to make it even simpler, anything you do in this classroom should be in that notebook. Anything you think about in this classroom should be in that notebook. Anything you learn in this classroom should be in that notebook. All right. So contents, when you're working on the project, when you're doing research, when you're doing sketches, when you're brainstorming, calculations. All right. Don't get an extra piece of paper and make your calculations that way. Do it right in your notebook. All right. Your daily thoughts and ideas. Any pictures. All right. You can take pictures, cut them out, paste them into your notebook. All right. As you work together as groups, maybe you want to put your meeting summaries in there. Maybe you've tested it and now you want to record your results and your conclusions. If you make some print-offs and print them off on the printer, maybe you have your technical drawings in there. All right. Also, very, very, very important. All right. If you make design modifications, all right, you go back and you change something, that needs to be in your notebook. When did I change it? And more importantly, why did I change it? All right. Once again, everything you do, think related to a design project should be in your notebook. All right. Sections. If you open up an engineering notebook that I give you or one that you buy on your own, don't buy it on your own. I'm giving you one as part of your fees that you pay to be in my class. All right. There is no one correct way except for my way in this class. Once you're out of here, you can do it your own way. Okay. The engineering notebook sections, they have a title page. They have a table of contents, and you see that over here. You can see in your engineering notebook, you have 4 or 5 of those pages, and you could just write. All right. Here on 1012, I did valve research. This page, 1013, I'm also doing valve research. You'll notice that there's page numbers here. All right. If I want to find when I did the pH sensor modifications or specifications, when I picked out what the pH sensor should do, I know immediately that I can go to page 26 and see what my thinking was in specifying that pH sensor. Um, the biggest part that you will enter is these general chronological entries. That's a fancy smancy words for those are your notes, those are your ideas, those are your sketches. All right, you have your references, and then if you meet somebody and you put all their contacts, or if you discover an expert, all right, you know somebody who is excellent when it comes to specifying a pH sensor, put their phone number in there. That way you don't lose it. All right, so standard page layout. This is what the page looks like from the general specification side, okay? It is quad ruled paper. Usually it's on a 1/4 inch spacing, but sometimes they differ, okay? So 4 of those should equal around an inch, all right? Lots of times. All pages are numbered. So if you see up here in the right-hand corner, all right, you'll see the number. Each page is also dated. All right, now you can do those in 2 places. You have it here, or you can go and date it inside here. You will notice that it is signed by the designer. Okay, and there's a spot for a witness. That witness is basically there if there's ever a question in a court of law as to when you did this. That witness will provide testimony that says, I saw Joe Smith sign this on this date, and that's why I signed it. All right, and then it's basically there's a little note that says this is proprietary information. It's not open to the public. It's mine. All right, so best practices. Once again, the idea is to keep as much detail and organization as possible. So there's no question about your design process and when it's completed. Okay, I will tell you this. You will see that the very first thing that's on there is all work is in pen. Okay, if you're an engineer, that's the way you should do it. Because if it's in pencil, who's to say you didn't 5 years from now go back and change it? And now, if you change a legal document, that's generally not acceptable to the courts. So that's why they say all work is in pen. However, all right, in my class, if you're not comfortable completing sketches in ink, all right, you are allowed to make some sketches in pencil. I suggest that you trace over the pencil sketches immediately when you finish, okay? But anything you write should be in pen, all right? Anything that you sketch in pencil, you should trace over with pen when you're done, okay? A lot of these are very, I guess, important for keeping it very neat. All right. You've noticed on your engineering notebook that you're writing on the fronts and backs of paper. If you use a Sharpie that bleeds like crazy from the back to the front or the front to the back, it makes it impossible to read. Okay. So if you get to page 56, but I can't read page 55, the page before, because I used a Sharpie that bled through, that's not good. All right. It removes the ability to read the data that you've already put in there. Okay. You will notice that the pages are sequentially numbered in ink on the top outside edge. All right. So you see the page number there. Also very important, notebooks are bound. Okay. From a legal point of view, if I can't add pages or remove pages without you telling it, then I know, all right, that document is, if it's dated properly, has not been modified since the day it's been signed. Okay, continuing what we do, what our best practices are in an engineering notebook. So entries begin at the top of the page. All right, you'll see we'll begin research right here, and they go left to right. All right, so you're going to fill it in this way, and then it's going to go top to bottom. All right. Do not leave blank spaces. if you have additional space, all right, draw an X or line and sign across it. All right, so you'll see here they have drawn this line here, all right, and they've signed it. I personally like to do an X. That way I don't have any temptation to write, in any of the extra spaces. I like to do an X and then I like to sign it. It's also permitted to initial it, but signature is probably a little bit better. All right, you'll notice here's a close up. All right, they have signed it. Very important. If you make a mistake, and you will make a mistake because everybody in here is human, all right, we all make mistakes. Draw a line through it, enter the correct information, and initial your change. You're never, ever, 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 ever to erase or remove anything. All right, so we look here. All right, they wrote Botox. I think they wrote Botox instead of borax. All right, so you'll see that they crossed it out and then they wrote borax, and then here Christopher Daniel initialed it. All right, same thing here. Cross it out, write what it really is, initial it, Christopher Daniel. This one I am not a fan of because they have done this, right? They've scribbled it out. It becomes very difficult to read what he has had there before, all right? So a single line through it is what you need. All right, it is very important to date in each entry. Okay, so you'll see here they have dated it. Took place on 5/15. If you want to be precise, all right, because if that said 1/2, if you want to be precise, it was better to say 2 January. Because is it 2 of January or is it the 1st of February? All right, because different parts of the world put the first number. It can be the month. In different parts of the world, it can be the day. All right, so I like to write out January, Jan, like 5, Jan. All right, 2016, 2017, whatever the date may be. All right, so make sure to date each entry. It is perfectly fine to add things to your design notebook. Maybe you have pictures. Maybe you have a printout of a test report. Whatever you want to paste or glue or tape into your binder, that is fine. Okay, as long as the items are permanently attached. Glue is preferred, but tape is perfectly fine if you have that instead of glue. But once again, glue is preferred. What you need to do, if you tape something into your engineering notebook, make sure to sign your name so it extends across both the notebook page and the inserted document. All right, so you'll see here they started on the pasted part, or I'm sorry, the taped part, and they moved across into the part of the engineering notebook. That way, if that photo is ever removed, you'll see half a signature, and that will tell the legal authorities or tell anybody looking at your notebook that something is missing. Okay? It is very, very, very important that you have no loose items in your notebook. Everything should be firmly and permanently attached to the notebook. All right, more best practices. Sign and date each page before the next page is started. Okay. In this class, another classmate or Mr. D will look at your engineering notebook and sign as a witness. You should, every 4, 5, 6 pages, get me to sign it. That way I can double check to make sure that you're following accepted best practices. Not that I want to check up on you, but I want to make sure you're doing it right and correctly. That way the entire notebook is useful to you. Okay? So make sure somebody signs it. Out in industry, that's typically the person who signs it doesn't really have any personal connections to the engineer. Typically, they like it even if that person doesn't work at the same company. because if you get someone from the same company, they have a personal um, investment in what the company is saying. So if you're saying I had this done and I worked for the Coca-Cola company and this is the day that I had it done, and you get somebody else from the Coca-Cola company, are they lying because they want to help out their company, or did they really sign it? So it creates some cloudiness in the legal process. So it's typically best to take it somewhere else and have some uninterested third party sign it. All right. That also means you can't take it home and have your, best friend or your spouse, if you happen to be married, to sign it. All right. It has to be some uninterested third party. It's important to store the notebook in a safe location. All right. That works if you're out in industry and you have a job, or especially if you're a ninth grade student and you're not used to keeping up with things for an entire year. You need to keep up with this notebook. I have a lot of students that keep it and continue it when they go to POE next year. All right. So keep your notebook in a safe location. So, more best practices. When it comes to sketches, you should label all parts of the sketch. Okay? You should have a name, its function, and its material if it makes sense to have so. I have a wheel bearing. It goes in the axle assembly of my bicycle, and it is made out of stainless steel and Delrin. Okay? It happens to be 2 inches in diameter. All right, so you're going to describe each sketch in detail. Think of it this way. What would you say if somebody asked you, what's this sketch? Okay, whatever you would say to explain that to them, write it down. All right, and this is called annotation, by the way. When you write a description, all right, and you draw arrows, that is called annotation, and you do it in drawings as well. So annotate all your sketches. All right. Calculations and figures are clearly labeled. So I have a picture here. Okay. It is clearly labeled as a picture of a prototyped wheel and axle subsystem. So figures are clearly labeled. All right. This is what this is. This is my axle subsystem. When I was designing it, here are the calculations that I created. So here we have the wheel and axle mechanical advantage calculations. You will notice that they wrote down the equation and what each of the terms mean. So here's the equation, here are each of the terms. Then they have their math. All right. This is super important. I know your math teachers tell you all the time, show your work, and some of you ignore that. That is not okay when it comes to engineering. Not because I just want it to be that way, because there will come a time when someone, maybe the person who is manufacturing this item for you, or maybe you have created a axle subsystem and somebody's gotten hurt. They were driving down the road, the shaft broke off, and they have now sued you. And so you're sitting in front of a judge and jury trying to decide if you are responsible for injuring someone else. All right? At that point, they will ask you, excuse me, Mr. or Mrs. Engineer, how did you determine that the bearing material was the proper kind? How did you determine that your axle subsystem can hold the weight of a fully grown bicyclist? All right, and you will show in your engineering notebook, because you've written it down properly and shown your work, here is the calculation that I used. This is the formula. It is perfectly acceptable in the engineering practice to use this formula. It is the correct formula. I use the correct terms. All right, and here is my work. My calculations were correct. And so it makes it very hard if you do all this properly for a attorney for the other side to prove you were negligent in your calculations. You can also make progress entries. and this is not directly related to the design itself, but maybe related to the project and the deliverables within that project. More of a project update than a specific item update. You may say, you know what, I came up with a way to use the wheel in my design. The weight seems to work very well, but as it spins so fast that I am getting some vibrations. The vibrations trouble me. I probably, as I move forward, should look at some way to dampen the vibrations here in this wheel. All right. You can also comment on your successes. Woohoo! I fixed the vibration. Or your failures. The vibration, I forgot to take it fully into account and it vibrated off the stand and broke. All right, boo-hoo. You can also use progress entries to reflect on things that you need to do in the future and things that you have that still need to be completed. All right. So if we look here, this chamfer creaks. Maybe we should have less surface contact, and I'm having way too much friction here, and I'm generating heat. It's getting hot. All right, so those are all progress entries. So to summarize, you, with your engineering notebook, need to be neat. All right, it should not have any extraneous scribble marks. I was bored that day and Mr. D was talking and I drew a cat playing with a mouse. All right, that kind of thing does not go in your engineering notebook. All right, you should make sure that there's not any extra marks lying around, or you forget and put your drink down on it and now you've got a nice drink ring in the middle of your engineering notebook, or you leave it in your backpack and your backpack I don't know, is left in the trunk for 3 days and it becomes all soiled and bent. All right, the pages should be nice and crisp. They shouldn't be all dog-eared. All right, it needs to be neat. It needs to be professional. It needs to be accurate. Whatever you put in there should be the truth. Okay, it's not a fiction novel. Okay, it's a non-fiction log of everything you did or saw or thought about a project or about this engineering class. And finally, the most important part is it needs to be legible. That means it needs to be easily read by anyone. All right, and that's not just something that teachers say, but it's also very important because maybe you have designed something, let's say 3 years ago, and it has all your calculations in it and everything, and somebody gets hurt, and they sue you. And you have to go back because you've not thought about this project in 3 years. And you have to go back and go, oh, what did I do? If you can't read your own writing, how embarrassing and potentially expensive could that be? Or if you're sitting in front of a jury and a judge and the lawyer for the other side, and he says, I don't know if what you're saying is true. Where's your proof? And you say, oh, it's all in my engineering notebook. And he says, but I can't read that. Can you read this, jury? Does this look like just chicken scratches? How do we know what they're telling us is true? I don't know because I can't read it. All right, so be legible. If you have to print, print. If you can write neatly in cursive, do whatever you need to do. If your handwriting is terrible, all right, you can practice, all right, or you can type it, print it out, paste it in there. And be thorough, all right. It's very, very, very important that you capture all of the information that you do, all that you do, all that you say, all that you create, all that you think about a project, and put it in your engineering notebook. All right? A 50-minute class period cannot be summed up in one sentence. Let me say that one more time. A 50-minute class period, it is impossible to sum that up in one class period. So each and every one of your entries for every class period needs to be thorough. All right, so let's look at some examples here. So this is Earl Silas Tupper. All right, um, this is from his invention diary and sketchbook. Mr. Tupper, you may have heard because he invented Tupperware along with a number of other items. All right, so he has a paint pot. Okay, so he has titled his page. He has dated and signed it. All right, what is he missing? He doesn't have a page number here. All right. Usually because this goes back quite some time, though it's not. It's 1939. He really should have had a regular engineering notebook with pages. What else is he missing? Oh, he doesn't have the witness, right? The witness who is witnessing this. But he does have a very nice sketch. It is a drawing of a paint pot. He has labeled its uses, its distribution. All right. Its patentable features. Where are the items that are new and novel and not obvious? Because I'm going to patent those and make no one be able to use those for 27 years. Okay. Here's another example. This is Everett Bickley. All right. He has created an electromechanical flycatcher. Okay, so we can see the title here. It's an electromechanical flycatcher. He has signed it. Once again, we are missing a page number over here. You'll see he's got some annotations. He has a very nice sketch, including some bait here. You'll see where he has labeled everything. All right, he even has some dead flies. All right, right there. He draws a nice sketch, and then he goes and describes the operation of this machine. All right, first flies are attracted by the bait. There's a light on the cylinder. The cylinder rotates, carrying the fly inside the screened box, and the fly eventually falls into kerosene and dies. Wow, that got really dark pretty quickly there. And that's his invention. Okay. Another example. All right. Howard Head has an original design for an oversized tennis racket in 1974. You will see a sketch, all right? You will notice that the inventor's signature and date, as well as a witness, all right, with a signature and date. So here, 5/28 in 1974. You will notice that he has dimensions on here. So here's some length. It's about 14 and maybe 3/4 inch long there. The overall width length of the racket is 26 1/4. All right, so he's describing everything about this racket he has designed. So two additional items unrelated to the engineering notebook. You will need a course binder for this class. Okay, it's not your engineering notebook. All right, you can store all your course material that doesn't go in the engineering notebook. All right, there are activities. There may be research that just doesn't really seem to go along. Maybe there's reference material, and maybe you'll do a printout or I'll have a handout. You can throw that into your course binder and keep it handy. Having said that, you still want to, in your engineering notebook, record the activities, what you did that day, okay? The parts of the research that you include in your design, you want to write into your engineering notebook. You can summarize, but it still needs to go in your engineering notebook. Reference material that you use in the design project. All right. Remember when we talked about the pH specifications, that reference material needs to go into your engineering notebook. All right. Handouts. All right. You can put that in your course binder, but you know, if it's something that you want to remember and keep and not lose, maybe you take sections of the handouts and put them into your engineering notebook. Okay. What I would do when you have a course binder, and really a 1-inch binder is perfectly fine. maybe even a 1/2 inch binder. Those seem to be hard to find though. Take the engineering notebook, and put it into your course binder. All right. Coincidentally, your engineering notebook has 3 holes punched all the way through it. It fits the metallic device, the metal device that's designed to hold items that have 3 holes punched through them. All right, that's in your course binder. If you want to keep your engineering notebook neat and clean and legible and looking spiffy till the end of this course, if you keep it inside your course binder. So if you protect your engineering notebook by a plastic wrapped piece of cardboard that is your course binder, it will look a lot better by the end of the class. And here's our references. So that's the end of the presentation. Thanks, guys.